Okay, so today I'm going to show you how to use the Pythagorean theorem a little more. We're going to prove if a couple problems are right triangles, and then we're going to do some where we're trying to find the side lengths, either the hypotenuse or a leg. So starting off here, example number one, I have a triangle, and I do not know if it's a right triangle yet, but I have side lengths 9, 40, and 41. Okay, so remember the Pythagorean theorem states if a right triangle, I'm going to abbreviate here. If a right triangle, then we have a squared plus b squared equals c squared, with a and b being legs. Okay, remember legs are the two sides that make up a 90-degree angle, and then we have c being the hypotenuse. Okay, so we're going to start with this one. Remember the hypotenuse, though, is always the longest side. Okay, so that's something to remember here, is the longest side. So we need to figure out, is this a right triangle? Because right now I don't know. It may look like one, but it doesn't matter if it looks like one. We got to find out for sure. And if it's for sure a right triangle, then this will work. So we need to plug these numbers in for A, B, and C. So going around here, I'm going to call 40A, and I'm going to call 9B, and I'm going to call 41C since it's my longest part of my triangle. So we're going to then have, we're going to use A squared plus B squared equals C squared. We're then going to have 40 squared plus 9 squared, and that's gonna, our question is that gonna equal 41 squared? Okay, 40 squared, well, you might need a calculator for that one. 40 squared is 1,600. Okay, and then we're gonna have plus 9 squared, which is 81. Okay, and then we're gonna be equal to, that's the question here again, 41 squared. Okay, if you don't know what that is, just type it in the calculator. All right, 41 squared is 1,681. So then we're just going to add these up. So we're going to add them up. We're going to have 1,681 equals 1,681. And that is correct. It works. So what we say in this case is, since Pythagorean theorem works, okay, since the Pythagorean, okay, I know it can be kind of tedious to write it out, but please do. Since the Pythagorean theorem works, you can abbreviate theorem. It is therefore a right triangle. Okay, something on the lines of that at the end. Okay, that'll be perfect. And for triangle, I don't care if you abbreviate it with a triangle. All right, so there's example number one. Okay, number two here, I want you to, once I get this one drawn here, I want you to try this one by yourself. Okay, so we're going to have a triangle with side lengths. Actually, here I'm just going to, let's go like this. A triangle with side lengths. We got 3, we got 5, and we got square root of 34. Okay, 3, 5 is square root of 34. So I want you to pause this one and give this one a shot. All right, so we're resuming here. Remember, if we're trying to prove if this is a right triangle, we need to use a squared plus b squared equals c squared. Okay, so we're going to have a squared. I'm going to call a 3. I'm going to call b is 5. And if you don't know what the square root of 34 is, just type in the calculator, but that should be the longest side, so that should be our c. So we're going to then have 3 squared plus b squared, which is 5 squared, equals c squared. I'm going to put this in parentheses here. We're going to have the square root of 34 squared, okay? So going through this problem, this is our question. We got to find out if they're equal. So we're going to have 3 squared, which is 9, plus 5 squared, which is 25. And our question is that equal to, well, what's the square root of 34 squared? Well, remember the square root and the squared cancel out, so it's just 34. Okay, so 9 plus 25 is 34, and that is equal to 34, so it works. So we would go ahead and write the same statement here. Okay, you guys should rewrite this. I'm not going to for time's sake. Okay, but that same statement should be written. You should say, since Pythagorean theorem works, it is therefore a right triangle as well. All right, number 3 here. This time I'm not going to draw you a triangle. I'm just going to give you side lengths. Okay, remember the longest side needs to be the hypotenuse. So I'm going to have 10, the square root of 90, and 14. So figure out if if a triangle with these 3 sides would form a right triangle based off this list of numbers. Okay, remember the longest side is the hypotenuse. When you think you got it, go ahead and resume the video. All right, so here we go. So I need to figure out what the square root of 90 is. Is that the biggest number here in this case? The square root of 90 is 9.486, so no, the square root of 90 is not the biggest number. So I'm going to call 10 my A, I'm going to call B my square root of 90, and 14 is going to be my C value. So we're going to use the Pythagorean theorem again. A squared plus B squared equals C squared. I'm going to plug these numbers in. So I'm going to have 10 squared plus the square root of 90 squared. Okay, make sure you put that in parentheses. Equals 14 squared. 10 squared is 100 plus the square root of 90 squared. That's just 90. The square root and the squared cancel out. Okay, and that's our question. Is it equal to 14 squared? 14 squared is 196. Okay. So add these up. We get 190 equals 196. Those are not equal to each other. So this is not a right triangle. So what we need to say in this case, since the Pythagorean theorem did not work, okay, since the Pythagorean theorem didn't work, okay, it is not a right triangle. All right, we need to say something along the lines of that for this type of problem. All right, so now I'm going to go into some where we have to find the missing side length. Okay, so here's an example. I'm going to draw a triangle up here on the screen. Okay, I'm going to have side length 6, I'm going to have side length 5, and I'm going to leave one side length blank. And here is our right angle. Since we know in order to use Pythagorean theorem, it has to be a right triangle. So we have to be given that. All right, so with this problem, okay, remember the hypotenuse is the side also opposite of the 90-degree angle, or it's the side that does not make up the 90-degree angle. So that is the side length that we are missing here. Okay, so I'm going to go ahead and label that with a C, and that is our question mark. Okay, so 6 and 5 are going to be our legs, so we should label those as our A and B values. Remember, it doesn't matter which one's A or B. So then we're going to use the Pythagorean theorem. A squared plus B squared equals C squared. Okay, we're going to put A is 6, so we're going to say 6 squared plus B, which is 5, so 5 squared equals C squared. So we're going to have an equation here to solve. All right, so 6 squared is 36, plus 5 squared is 25, and that is equal to C squared. Okay, so now we need to add up 36 and 25, which would be 51, which equals C squared. Now you got to remember the opposite of squaring a number is taking the square root of both sides. So I'm going to take the square root of both sides. So the square root of 51 then from the calculator says it is 7.14. Okay, and that's rounded to the nearest hundredth. And that is going to be equal to C. We do not have to worry about the negative value here because a side length you can't have a negative side length. That doesn't make sense. It's like you can't have a negative distance. Okay, so we just have to worry about the positive here. And that is our C value, 7.14. All right. So let's go, here's example number, say 5 for this. Okay, so here's a triangle. I'm going to draw this one a little bit different. Still going to be a right triangle though. Obviously my picture's going to be off a little bit. Okay, I've got side lengths 12 and I got side lengths of 4. I want you to find the missing side length now. Okay, I want you to find the missing side length. When you got it, please resume the video. All right. So same thing again, since this is a right triangle, we can use A squared plus B squared equals C squared to find the missing side length. Okay, I'm going to call A 12, I'm going to call B 4, and C is our missing side. We're missing the hypotenuse. Okay, so we're going to have 12 squared plus 4 squared equals C squared. Okay, 12 squared is 144, plus 4 squared is 16, and that is going to be equal to C squared. Okay, then we're going to add 144 plus 16 together, and we get 160, okay, equals C squared. Then we need to take the square root of C squared, and we also need to do it to the other side. So then we're going to get C equals, rounding to the nearest hundredth, 12.65. And that is how long our hypotenuse would be. All right, so we got 2 more here, and then we're done here. Okay, question number 6. Okay. This time, I'm going to give you something a little bit different. Okay, we still got our right triangle here. I'm going to call it, say the hypotenuse is 7 centimeters. Okay, and I've got a leg that is 3 centimeters. Okay, so we are missing a leg in this case. Okay, but since it's still a right triangle, we can use Pythagorean theorem. So we're still going to use a squared plus b squared equals c squared. You still need to label your sides. I would call a 3. C is not going to be b. Our c is going to be 7 centimeters. Okay, I'm going to call a 3. We're going to be missing our b value. That is the question mark, not our b squared, just our b value. Okay, that's what we need to find. So plugging these in, we're going to say a, which is 3 squared, plus b is our unknown, so we're going to say b squared, equals c squared, which is 7 squared. Okay, so now solving this here, 3 squared is going to be 9, plus b squared stays the same, equals 7 squared, which is 49. Now just solving this equation, you got to get b squared by itself, so we need to minus 9 first, using our solving equation skills. So then we have b squared equals 49 minus 9, which is 40. Then take the square root of both sides, get rid of that squared finally. So you get b equals, let me type this in a calculator here, I don't know what that is off the top of my head. It should be 6 points. So you write in nearest hundredths, 6.32. Now this one has units, so we better include units. It's 6.32 centimeters long. Okay, 6.32 centimeters long. All right, so here's number 7 here. I want you guys to try this one now. Oops. Kind of a bad, I'm not very good at drawing pictures here. Let's say here our hypotenuse is 37. I got a side length of 12. Okay, I want you to find the missing side length. All right, so when you think you got an answer, go ahead and resume the video. All right, so same thing goes here. We should label our sides right away. We have a equals 12. Oh, I forgot to give you the right angle. It's my fault. As you want to be able to solve that. Okay, and then but c is going to be 37. And I'm going to leave my b value as the missing one. So we're going to have a squared plus b squared equals c squared again. Is the reason Pythagorean theorem. So we're going to have 12 squared plus b squared equals c squared, which is 37 squared. 12 squared is 144 plus b squared equals, 37 squared. I don't know what that one is. It's probably going to be a big number. 1,369. Okay. So then you need to get b squared by itself, so we need a minus 144 from both sides. So I do that. So I get b squared equals, let's see here, that's going to be 1,225, which then we need to take the square root of both sides. So we get b equals, I believe it's going to be 35, but don't quote me on that. Yeah, 35. So we have b equals 35. Now I don't have units on this one, so that's all it's going to be. So we have a side length of 35 that is missing. If you have any questions, please let me know. Let's have a great rest of your day.